Okay, good afternoon. I'm Ji-Yong Shin from Northeastern University, and I'm going to present a proposal for a more general serverless framework for supporting more diverse applications. So this work is in collaboration with Abraham from So I guess I want to first talk about, I guess for those who are not familiar with what serverless computing is, I want to first talk about what it is. So serverless computing is a new programming paradigm in the cloud, I guess. Serverless platform abstracts away the server usage or VM management at all. So users get to write simple program logic in the form of function. Then they just deploy it into the cloud. And then what happens is that whenever the user or user of the program needs to run that program, they would trigger an event or send a request to the cloud. Then the cloud provider will on demand execute that piece of code, often called a function. And the benefit of the serverless computing is that users don't have to get involved in maintaining any of the resources that's happening behind the scenes, and the serverless providers will automatically scale them, manage them, and only charge for how much compute that the function instance has triggered. So then, why am I proposing to augment the serverless framework to host general applications, and what do I mean by that? So serverless framework, as good as it sounds, it also has a lot of limitations. So current serverless computing applications are more optimized for compute-only tasks, and if you have to deal with continuous states that outlive your computation, or if you have to do some networking operation and so forth, then you'll hit a limitation. So from the user point of view, if we can enable a more general application in this domain, then they will obviously benefit from these auto-scalability and all these features provided by the serverless framework. From the cloud vendor point of view, if you can support a more general application, then you can have more customers and a large set of applications running in your framework. So the high-level goal of this proposal is to enable general applications or systems to run on the serverless platform. So today, as I mentioned, compute-centered applications are mostly running in the current serverless framework. What we want to do is we want to support stateful application. There is a lot of research ongoing to support such applications. We want to, however, move a step further to even build backend cloud systems that people generally use from the serverless instances. So we want to even build backend system using this paradigm. So we're going to use a file system purely built out of this serverless paradigm as an example to drive this project. So the general objectives, some detailed steps that we plan to pursue are investigate a new design or new features that could augment the serverless framework to support these more general applications. So augment the framework with some serverful service, meaning VM-based services that could really augment and enable more general applications. And then also we want to give back some control to the users in terms of how they can manage the resource. In the serverless environment, all the resource managements are happening by the backend cloud, and we want to give some feedback back to the user so that they can fine-tune the resources, and also vice versa, users can give some resource usage hints to the serverless provider so that they can optimize internally how they consume resources and prepare resources for the application. So we have a prototype file system that is purely built out of a serverless paradigm. Well, it's not purely serverless because it has some serverful components. So our file system is built on top of backend key value storage system that most serverless applications rely on. But the file interfaces are purely implemented as serverless functions. So there are client libraries that enable us to access these serverless functions to access the files. But the caveat is we weren't able to purely build the serverless file system using these function instances because there are some auxiliary stateful services that we would need in terms of making the file system perform very well. So there were some considerations in terms of building this file system, such as how are we going to control concurrency. For example, we're pinning like a special function per file so that there isn't concurrent access to a persistent file. There needs to be some caching support in terms of improving the file accesses, transaction support, atomicity support, states, metadata management, and so forth. So all these features, unfortunately, weren't able to efficiently implement it using serverless functions. We believe these serverful implementations could be migrated into the serverless framework in a smarter manner, such that these kind of features could be used in a more useful way to support other general applications. So the steps that we plan to take is using this file system as a driving example and try to break down the serverless file system components and deep dive into what kind of feature would be really helpful in terms of supporting generalized application. So Abraham has been working on designing a cost and performance analysis tool that would divide up a general serverless application into serverful versus serverless components. So that kind of principles can be applied into our file system in terms of what would be best to run on the serverless part versus serverful part. And based on that analysis, the serverful part can be deep dive in, and then we can extract some features and then iteratively migrate that necessary feature into the serverless framework. As a second thrust, we want to optimize the resource usage, both from the serverless user point of view and from the cloud provider point of view. This is another ongoing project where we want to give continuous feedback from the serverless framework to the users in terms of how much cost that they're spending, how much resource they're spending, and how much performance you're getting out of your configuration, such that users could iteratively control the amount of resources that they're using. And something that we plan to design in the reverse direction is to create a new interface such that cloud providers can get some hints from the user, such that the cloud provider can optimize the placement of resources. So for example, in a file system design, when we want to design a page cache for a file system, then that memory component would benefit if that memory component is co-located with the serverless function that is processing a particular file. So such a co-location could be enabled only if there is a user-side hint. So the way how current resource allocation works is almost working based on blind information. So we want to at least provide some interface where both serverless users and providers can benefit. So some deliverables and outcomes include identification of some missing features for supporting these generalized application and serverless frameworks. We would like to deliver some at least open source or openness-based serverless framework with these augmented features. We want to also provide some fast performance and resource analysis tools. And of course, the file system, the main applications that we've been using to derive this project, which should be efficiently run. In terms of impact, assuming everything goes well, then we will be able to run even more diverse application, not just a file system like backend services. We're thinking of even building like a backend key value store on top of it. Some applications that weren't generally well supported in the serverless application would be runnable in this domain. We want to also enable better resource utilization, so the outcome of the tools would allow us to give better feedback to the user as well as Yep, so in terms of project duration and budget, we were looking at 1 year, but if the collaboration with the industry goes well, we can look beyond that. And at the same time, we want to have like a 2 PhD student working on this project. Yeah, and that's pretty much it. Thank you.
Any questions?
I'm going to ask the benchmark questions again. How is that going to compare to existing file systems?
So I guess it's a distributed file system, so it's so it would be comparable to something like a Ceph or like a GFS, like a distributed file system. So if you were to test this kind of file system, the application or benchmark that you would run could include like YCSV like workload, or we have plans to also port some local file system benchmark into this distributed setting if we can make the interface compatible.
Any other questions? All of our industry folks are completing their review. Thank you.